Functions and linear models, page 1. A function is a relationship between two sets, a first set and a second set. Each element of the first set, x, is related to one and only one element, y, of the second set. Sometimes we call the x value the input and the y value the output. So basically, each input goes to one output. Okay. Sometimes two different inputs might go to the same output, but you never have one input going to two outputs. And I drew these pictures here so you can see that a little bit better. This is not a function because the left inputs, some of the left inputs like C don't go anywhere, and that's not allowed. Okay? This is also not a function because one of the inputs, C, goes to two different outputs, and that's also violates the definition of a function. Finally, here, this is a function, okay? Every element of the left side goes to some element of the right side. And, even though B and C both go to the same value, that doesn't matter because they both go to one value, okay? And you can have two inputs going to the same output. That happens, okay? So these are three images to keep in mind when you think about what a function is. Now let's look at number 1. Mrs. Urquiza and Mr. Genzer both teach math. Mick and Lucy are in Mr. Urquiza's class, and Lydia and Diana are in Mr. Gensler's class. So let the set of students A be Mick, Lucy, Lydia, Diana, and the set of teachers B be Mrs. Urquiza and Mr. Genzer. Okay, decide whether these relationships are functions. Justify your decisions. Okay. So let's just write out what they wrote here in letters. So we're going to say, okay, Mr. Urquiza and Mr. Genzer, Mrs. Urquiza and Mr. Genzer both have math classes. Mr. Urquiza has Mick and Lucy, and Mr. Genzer has Lydia and Diana. Okay, so that's just to understand how the classes are set up. Okay. Now let's look at the two relationships they're proposing. First, they're saying the relationship between the first set A and the second set B is X is in Y's math class. Okay, so we're talking about Mick, Lucy, Lydia, and Diana. So Mick, Lucy, Lydia, and Diana are in set A. Okay, and set B has the two teachers, which are Mrs. Urquiza, and Mr. Genzer. Okay, now let's draw the arrows to show who's in whose class. So Mick and Lucy are in Mr. Urquiza's class, and Lydia and Diana are in Mr. Genzer's class. So that looks like this function here, or this relationship, which is it looks like this function, this relationship, which is a function. Okay, so yes, this is a function. Okay, and you can say something like x is related to one and only one element of y. Okay, so you could say x is related to, one and only one element of y. Okay, that's your reason why you say that's a function. Okay, now what about B? X is Y's math teacher. Okay, so now we're saying the input is U and G, Urquiza and Genzer, and then we have the students on the left side. And then we draw our arrows like this. Mrs. Urquiza is Mick and Lucy's teacher. Mr. Genzer is Lydia and Diana's teacher. So now we have, it looks kind of like this one here, where you have one input mapping to two different outputs. And remember, that is not a function. Okay, so it's not a function. And the reason why is because one input maps to two outputs. So then we know it's not a function. Okay? Number 2. So we have two sets. We have the set 3, 7, 10, or we have three sets, 12, 16, 49, and 100, and 49 and 100. Decide whether these relationships are functions and justify your decision. Okay, let's see. We're going to look at set A and set B, and we're going to say the relationship is x is a factor of y. So we're going to put 3, 7, and 50, and then and we're going to put 12, 16, 49, and 100. And we're going to say x is a factor of y. So this is x, and this is y. And let's see. 3 is a factor of 12 only. 7 is a factor of 49 only. 50 is a factor of 100 only. Okay, so is this a function? Looks okay because every x maps to one y. Okay, so yes, this is a function because every x maps to one y. Okay? All right, let's look at the next one. The first set B, second set A, and the relationship is x is a multiple of y. Okay, so let's try that. So we'll have B, which is 12, 16, 49, and 100. And then the y is set A, which is 3, 7, and 50. And the relationship x is a multiple of y. So 12 is a multiple of 3, 16 is a multiple of, oops, nothing, 49 is a multiple of 7, and 100 is a multiple of 50. So 16 doesn't map anywhere. Is that a problem? Yeah, it is. That's this first case here. Do you see when there's an input that maps to nothing, that is not a function. Okay? So not a function. And the reason why is because 16 maps to, oh my gosh, 16 maps to nothing. Okay? Last one. Now we're going to map C, 49 and 100 to set A, which is 3, 7, and 50, and the relationship x is a multiple of y. So 49 is a multiple of 7, and 100 is a multiple of 50. And 3 is by itself. Is that a problem? No, it's not a problem. If you have each element of the inputs mapping to at least one output, it doesn't matter if all the outputs are accounted for. Okay? So in this case, yes, it's a function. And the reason why is because each x maps to one and only one y. Okay? Now let's move on to number 3. Okay, number 3. Decide whether these relationships are functions. Set A and set B. So we're going to say set A is 1, 2, 3, 4. Set B is 2, 4, 6. And it says the relationship is x is half of y. So 1 is half of 2, 2 is half of 4, and 3 is half of 6. Is that a function? No, it's not, because look, 4 is by itself, okay? So not a function, okay, because 4 maps to nothing. Okay. What about the next one? The next one is set A and set C. So 1, 2, 3, 4 is set A. Set C is 1, 2, 4, 6. And the relationship is x is half of y. So 1 is half of 2, 2 is half of 4, 3 is half of 6, and 4 maps to nothing. Okay, again, not a function. Because 4 maps to nothing. Okay, same thing. Okay, next one. Set C, then set A. So let's see, set C, which is 1, 2, 4, 6, and set A, which is 1, 2, 3, 4. And then the relationship is x is double of y. So 1 is double of nothing. 1 doesn't map to anything. 2 is double of 1, 4 is double of 2, and 6 is double of 3. Okay, but 1 maps to nothing. So again, not a function because 1 maps to nothing. Okay, that was number 3. Let's do number 4. First is set B, then C. So B is 2, 4, 6, and C is 1, 2, 4, 6. And the relationship is x is equal to y. So 2 is equal to 2, 4 is equal to 4, and 6 is equal to 6. Is that a function? Yes. It's a function. Okay, and the reason is because each x maps to 1 y. Okay? Last one, number 5. C and A. So we're going to have 1, 2, 4, 6, and 1, 2, 3, 4, and the relationship is x is equal to y. So 1 is equal to 1, 2 is equal to 2, 4 is equal to 4, and 6 is, so 6 maps to nothing, so not a function. Not a function because 6 maps to nothing. Okay? Alright, last one, number 4. Describe the following relationships between x and y using equations. Okay, so y is double x. Y equals 2 times x, right? Half of x is y. Half of x is y. Okay? Cubic root of x is y. Cubic root of x. Cubic root of x we write like this. Cubic root of x. Cubic root of x is y. Okay? Half of a cube of x is y. Half of a cube of x. A cube of x is like that. Half of a cube of x is y. Okay? And normally with functions we write y first. Like we write y equals something, something, something. So for these that are reversed, you could just reverse it and say, hey, the function is y equals 1/2 x. The function is y equals the cube root of x. And y equals 1/2 x cubed. Okay? And that's it for page 1.